We're going to be looking at classifying a system of equations by according to if they are independent, if they're inconsistent, or if they are dependent. This is kind of going to go with what we discussed in the last video about how many solutions are we going to have, but now we're going to put a label to how many solutions we have as well and classify them. So if we have these graphs, the first thing we could see is we have independent, okay? Which means that there's exactly one solution. It means that the slopes are going to be different, the y-intercepts are going to be different, and these are going to be independent lines of one another. However, we would label this as consistent as well. So if we had one solution, we could say that this graph is consistent and independent. Okay, the lines are not depending on each other. They are two different lines with two different slopes, two different y-intercepts. If we had graphs that were dependent or equations that were dependent, it means the slopes are the same and the y-intercepts are also the same. And we could also classify these as being consistent as well. So we could say these are consistent and dependent. They are the same line. They're going to be infinitely many solutions. If the graph is inconsistent, that means the slopes are the same, but the y-intercepts are different, where we also can see we have these parallel lines. We have no solution to this system of equations. We could also classify this as being inconsistent. So here we have just if we didn't have the graphs, how would we be able to classify these system of equations? Okay, so they can be classified as follows. If the slopes are the same, but the y-intercepts are different, the system is inconsistent, okay, which means that this is also no solution. So everything we kind of worked on in the last examples from the last video can still apply. We want to see how many solutions there are, and that's going to help us to determine how to classify the system of equations. If the slopes are different and the system is going to be consistent and independent, which means there is only one solution to the system of equations. And then if the slopes are the same and the y-intercepts are the same, the system is consistent and dependent. So this is going to tell us that there is infinitely many solutions to this system of equations. And that's where it'll be really good as we're practicing with this, because we'll still use what we had practiced before, but now we're just going to add a little bit more detail to it. So let's look at an example of this. If we want to describe the system of equations, and our answer choices are, we can select inconsistent, we can select consistent and dependent, or we can select consistent and independent. Okay, so again, inconsistent, we're going to have no solution. For consistent and dependent, that's going to be infinitely many solutions. And I'll just put infinitely many. And then for inconsistent, or I'm sorry, consistent and independent, there's only going to be one solution. And so now we can kind of look at this and we can do what we did before. And we could say, okay, first thing, we want to check our slope of the line to see if they're the same or are they different. And then we also want to check our y-intercept of the line to see, are they the same or are they different? Now remember, if the slopes are different, that means that we can automatically eliminate no solution and infinitely many solutions because there's only going to be one solution. If the slopes are the same, that's where we want to move, and we want to check the y-intercept as well. And we use the y equals mx plus b or the slope-intercept format to do so. So our slope is this m, this number that will be in the place of m or in front of x, and our y-intercept is going to be where plus b is going to be. And remember, the y-intercept doesn't always have to be plus b. It can be minus if there's a negative sign or a minus sign attached to that number. So let's first look at the first equation. We've got y equals 7/9 x plus 5. And so we want to first check our slope. our slope of this line is going to be 7/9. It's the number in front of x. 7/9. And so now we can check the second equation, which is y equals 7/9 x plus 9/10. So our slope is also going to be 7/9. And so we can say that our slopes of these lines or these equations will be the same. Now, because they are the same, we can eliminate that answer choice of one solution. One solution will not be the answer because remember, one solution has different slopes, different y-intercepts, mainly different slopes, which also means that this graph will not be classified as consistent and independent, okay? And that's why it's really important to kind of understand which one associates to which classification so that you can eliminate it as you're going through the answer choices. Then once we've checked the slopes, now we want to check the y-intercepts. We want to say, okay, our y-intercept of this line is this +5. It's this in place of plus b, so we would have a +5. And our y-intercept over here is going to be a 9/10. So we can say that in this case, our y-intercepts are different. So if the slopes are the same and the y-intercepts are different, we know these are going to be those parallel lines if we graphed them. And so that means that we're not going to have a solution. That means that we will have no solution. They will never cross, they're never going to meet, they're never going to intersect, which means that we can also classify this as being an inconsistent system of equations. All right, so we're going to move on to the next example that we have. So our next example, we still have the same answer choices that we can choose from, either being inconsistent, consistent and dependent, or consistent and independent. And so we want to remember that inconsistent is also no solution. Consistent and dependent is infinitely many solutions. And consistent and independent is only one solution. All right, and so the first thing we want to check is our slope. And then if the slopes are the same, that's where we will move to check the y-intercepts. And we will be using slope-intercept form of y equals mx plus b. So this number in front of m will be our slope. And the number that we have for plus b will be our y-intercept. So the first equation is y equals 5x plus 3/4. So we want to check our slope first, and we have a slope of 5, number that is in front of x. Our second equation, we have a slope. We have y equals 2/5 x plus 5/4, which would mean that our slope is 2/5. It is the whole fraction in front of that variable of 2/5. So we can say the slopes of these lines are different, which means that's actually going to eliminate two answer choices for us because it's going to tell us that this is not going to be inconsistent. Remember, inconsistent is no solution, okay? If the slopes are different, it means we are going to have one solution. So it also means we're not going to have infinitely many. It means that our answer here is one solution, which we could also classify as being consistent and independent. Think of it this way too. Think about independent. If you think about inconsistent, means no solution, right? Inconsistent. There is no answer. If you think about the other two, consistent and dependent, inconsistent and independent, maybe you're struggling to decide, how do I determine which one is which? Think about independent being they are two separate lines. The slope is different, okay? So they're independent. That means there's one solution. Now, if they're dependent, they rely on each other and they are going to basically be the same line, and they're going to have infinitely many solutions. They're going to depend on each other, and every solution, every point on each of those lines will work as a solution to the system of equations. So that's where we can say, since the slopes are different, we can say there is going to be one solution, which means that this is going to be consistent and independent. All right, let's look at another example here. So now we have which describes the system of equations below. Okay, and our answer choices will stay the same. We have inconsistent, which is no solution. Consistent and dependent, which is infinitely many. And then consistent and independent is one solution. And I know that I'm labeling these for each one of the examples we're working on, but it's really important to kind of start to be able to associate which one goes with which. So be able to look at inconsistent and know that means there's no solution. Be able to look at consistent and dependent and think that's infinitely many. And then look at consistent and independent and know that that's one solution. So we're going to check our slopes. We're going to check the y-intercept, and we're going to use the slope-intercept form to do so. So our slope is going to be the number that's in front of x or in place of m, and then our y-intercept will be for b. So first thing we're going to look at is our slope of each line. Our slope of the first line, we've got y equals negative 8x plus 5, 6. So for this equation, our slope is negative 8. And then for our second equation, we have y equals negative 8x plus 5, 6. So our slope is negative 8. So that means the slope of these lines are the same, which means we can eliminate one answer choice. We can say that that's definitely going to mean there's it's not one solution. There's either no solution or infinitely many. Because remember, if we had one solution, it means the slopes are different. So in this case, we would say the slopes are the same. That is not going to be an answer choice, which also means consistent and independent is not going to be used to classify the system of equations. Then we're going to check the y-intercept of both of these equations. So the y-intercept of the first one is going to be 5 over 6, and the y-intercept of the second equation will also be 5 over 6, which means the y-intercepts are the same, which also is going to tell us that these are not parallel lines, okay? Which means if it's not a parallel line, it means that our answer is not going to be no solution or inconsistent. It means that our answer is going to be infinitely many solutions. They're going to be the same line that are right on top of each other, that run together. All of the points on those lines will work as ordered pairs or solutions. So we could also classify this as being consistent and dependent. They depend on each other, those lines. All right, let's look at another example here. Got a couple more examples to practice. So which describes the system below? And we have inconsistent or no solution. We have consistent and dependent, which is infinitely many solutions. And we have consistent and independent, which is one solution. We're going to first start by checking our slopes, and then we're going to check the y-intercepts using the slope-intercept form. We know that our m is the value for our slope, and we know that plus b is going to be the value for our y-intercept. So the first thing we want to look at is the slope of our lines or our equation. Slope, slope. And so in this first equation, we have y equals 7/9 x plus 2/7. So this fraction that's in front of x, that is going to be our slope. 7/9 will be our slope of this equation. And then our second equation, we have y equals 3 halves x plus 9/7. So it will be this fraction of 3 halves. So we can say the slopes of these lines are different. They're not the same fraction, they're not the same number. Okay, so they are different, which means that we don't really need to continue any further because we can eliminate that it's not no solution. Remember, no solution is the same slope but different y-intercepts. So this would not be our answer. And then we can also eliminate infinitely many solutions because that's going to mean that the slope is the same and the y-intercept is the same. And so we can eliminate that and consistent independent. So our answer for this system of equations would be one solution, or we could classify it as consistent and independent. Independent meaning that the lines are two separate lines. Eventually they will cross, but they do not rely on each other. They are independent lines. They have different slopes. And the reason why we don't say with one solution that they have different slopes and different y-intercepts is because sometimes the y-intercepts might be the same. Maybe that's where they cross. Maybe that's where those lines will meet, is at that y-intercept. And so the y-intercept can be the same if you have one solution, but the slope, it's important that the slope is different. All right, so let's look at another example we have. So now we have this system of equations. We've got y equals 3x plus 2, and we have y equals 3x plus 9/7. So we have our answer choices: inconsistent, which is no solution. We have consistent and dependent, which is infinitely many solutions. And we have consistent and independent, which is one solution. And for the purposes of this video, I am labeling them so you can kind of practice with associating inconsistent is no solution. But again, it's very important that we start to kind of identify if we have inconsistent, that means no solution. So if we're looking at our slope and our y-intercept and we see, okay, there's no solution to the system of equations, we would know that that's going to be classified as inconsistent. And so the first thing we want to check is our slope. And then the second thing we will check is our y-intercept. And we're going to use slope-intercept form of y equals mx plus b, where our slope is our m and our plus b will be our y-intercept. And again, it does not always have to be a plus b. It might be a minus. It depends on what sign you have, what operation are you adding or subtracting. So the first equation, we have y equals 3x plus 2. So the slope of this line, we're going to look at that variable x, and we're going to see that number in front of x is a 3. That is our slope. And then over here, we have our slope, y equals 3x plus 9/7. Again, we're going to look at that variable x, and we're going to see there's a 3 in front of it, and that is our slope. So we can see that the slopes of these lines are the same. Since they are the same, we can eliminate this answer choice of one solution because that would tell us one solution, the slopes are different. And so one solution, this is not going to be correct. We can also eliminate consistent and independent because we know the slopes are the same, they're not different. Then we want to check our y-intercepts of the equation. So our y-intercept of the first one would be plus 2, would be whatever's in place of b, and then y-intercept over here would be 9/7. So our y-intercepts will be different for these equations, which is going to tell us that this slope is the same, but the y-intercepts are different. These are not the same line. Remember, if it's infinitely many, it means that it's same y-intercept, same slope, and so this is not consistent, independent, and infinitely many would not work. These are actually going to be parallel lines. The slope will be the same, but the y-intercepts are different. They're going to run parallel to one another, never going to meet, and they're never going to intersect. So there's going to be no solution, or we can say this is inconsistent. All right, and one more example that we have here to practice. We have to describe this system of equations. Remember, inconsistent is no solution. Consistent and dependent is infinitely many solutions. And consistent and independent is one solution. And we want to, again, check our slope. We want to check our y-intercept. And we're going to use slope-intercept form of y equals mx plus b, where we know that our slope is our value of m, and b will be our y-intercept. Now, the thing about the system of equations, if you've already looked at this example, 6x minus y is equal to -6. That is not written in slope-intercept form. That's in standard form, okay? And so I encourage you to, because it is easy to see once we have it in slope-intercept form, it's easy to pick out what's my slope, what's my y-intercept. So I encourage you to rewrite this into slope-intercept form. And how we're going to do that is we have to remember that y needs to be alone. And so we need to get this alone by moving this to the other side. And how do we move it? We're going to use those inverse operations. So we have a positive 6x. So inverse would be to subtract. Minus 6x minus 6x. And this will cancel for us over here. And now we have negative 6x, negative 6 minus 6x, which one of those numbers has a variable and one does not. And so that means that we cannot combine these terms. We can just leave these as is, negative 6x minus 6. And I did rewrite it to put the variable first. Okay. But now we also need to look at this y. And while it does look like it's kind of alone, it does have that negative sign attached. So how do we get rid of the negative sign? We're going to divide by a -1. And the reason why we divide is because if we had this coefficient in front, we would be saying -1 times y. And so inverse of multiplication would be to divide. And that means that this will cancel for us over here. And then we can also say we're left with exactly what we wanted, y by itself. -6 divided by a -1 is going to change to a positive 6x. And then same thing here, -6 divided by -1 will be a positive 6. So now we can look at our slope and our y-intercept pretty easily. We could say, okay, my slope here is this number in front of x, which is just a 6, positive 6. And then my y-intercept would be this number in place of b, which is, again, a positive 6. So it's a little bit easy to pick that out once we have it in slope-intercept form. Now that we've been practicing slope-intercept form for a while, we can see what my slope is, what my y-intercept is, pretty easy. But if it's not written in slope-intercept form, it will require a couple more steps. Our second equation, we have 18x minus 3y is equal to -18. So again, this is not written in slope-intercept form. And so how do we do that? We're going to move this to the other side, try to get y by itself. And so we would subtract 18x from both sides. And this will cancel for us over here. Now on the other side, we have -18 minus 18x, which those one has a variable and one does not, so we can't combine those. Remember, we can only combine terms that are like terms. And so we would just leave this as -18x minus 18. We want to still get y by itself, so we're going to divide everything by this number that's with y, which is a -3. Because if we knew what y was, we would multiply -3 times y. So we're going to divide everything by -3, which will give us y by itself. And then -18 divided by -3. The signs, we've got negative signs for both. And so that is going to result in a positive answer. And 18 divided by 3 will give us 6x. And then -18 divided by -3 will give us a positive 6. So now we can look at the slope. We can see, okay, the slope of my line will be a positive 6. And my y-intercept will be a positive 6. So we can see that, okay, if we compare the slopes are both 6. So we could say the slope of these equations will be the same. So in that case, we can eliminate that answer choice of one solution. One solution would tell us the slopes are different. Since we can see here that the slopes are the same, we can say that this is not one solution, so it's not going to be consistent and independent. We look at the y-intercepts, we can see that the y-intercepts of these equations are going to be the same as well, which means that these are not parallel lines. They're actually going to be the exact same line. So again, we can eliminate that answer choice of no solution. Remember, no solution is going to tell us we have parallel lines. They're never going to cross, never going to meet. There's not ever going to be a solution to the system of equations. And in this case, there will be a solution. It'll be many, many solutions. And so we could say our answer for this is going to be infinitely many solutions because they are the same exact line, same slope, same y-intercept. We could also classify this system of equations as being consistent and dependent. They are the same line, they are dependent on each other.